I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking another test question from quadratic functions. This has been requested by one of our students, and as per the request, we'll also provide solutions in alternate methods so that it makes sense to most students globally. As you can see, the question has been directly taken from a test paper, and I hope it will help you prepare and do extremely well in your own exam. Let me also thank all the viewers and subscribers for watching my videos, posting excellent comments and remarks, and their consistent support to us. Feel free to contribute as we have undertaken many projects to reach students even in tribal areas. Your contributions make huge difference. Be a part of this change. Thanks for sharing the passion of learning. So the question here is, a water balloon is catapulted into the air from top of a platform. The height h in meters of the balloon after t seconds is h equals to minus 1.25 t square plus 7.5 t plus 2.5. Three parts of this question are: when will the balloon hit the ground? B. What is the maximum height reached by the balloon? C. When will the balloon reach its maximum height? Extremely common question from test point of view. Almost every test paper on applications of quadratic functions will have a question like this, correct? Now, what is scary about this? The only thing scary about this is the decimal values which we are looking at: 1.25, 7.5, and 2.5. Well, clearly, you need to apply the quadratic formula to solve this question. Well, it looks scary, right? Only because of the decimal numbers. But well, when you use calculator, it really doesn't matter. So let's review the basic concepts. If you are given a quadratic equation of the form y equals to ax square plus bx plus c, and we want to equate that to 0, then what is the value of x? Well, that is the solution of this equation, correct? Equation using the quadratic formula can be solved as x equals to minus b plus minus square root of b square minus 4ac over 2a. The term 4ac is also called discriminant. Now look here, the equation which we are given is h equals to minus 1.25 t square plus 7.5 t plus 2.5. Now if you compare, our independent variable is t, the time in seconds, and we also know that the value of t is greater than equal to 0. Perfect. So equating this to 0 will give us when will it hit the ground, correct? So when the balloon hits the ground, it really means what? The height is 0, right? Now you see, it becomes same as solving an equation, and so we can use the formula. So in our equation, what is the value of a, b, and c? Well, the value of a to use this formula is minus 1.25, b is 7.5, and c is 2.5. So let's plug in these values and find the answer. Correct? Simple as that. You can always pause the video, answer this question. In case you want to learn from me, feel free to send an email on the address globalmathinstitute@gmail.com. We can be part of your success story. Well, remember, I'm going to share with you alternate methods also, right? So let's first go through this one. Okay, applying the formula, we can say the independent variable time t should be equal to negative of 7.5, right? Plus and minus within square root negative 7.5 whole square minus 4 times a, which is negative 1.25 times c, which is 2.5, right? Let me squeeze it in, right? 2.5 square root divided by 2 times a, which is negative 1.25. Right, so let's use the calculator to find this value within the radical, right? So let's use the calculator. What does it give us? So negative 7.5 square is as good as 7.5 square. And from this, there are two negatives inside. We'll make it positive 4 times 1.25 times 2.5, and that is equal to 275 by 4. I'm going to take square root of that, right, of our answer, and that gives me a value. Let me rewrite this as approximate value of 8.29, right, divided by negative 2 times 1.25 is minus 2.5, correct. So we get this. Since the time is greater than 0, we have to take all the negatives and then we'll get a positive time. So we'll add 8.29 with 7.5 and then divide this by 2.5 to get a result. And our result is 6.3. So I'm going to round this to one decimal place and write it as 6.3 seconds. So the ball actually hits the ground 6.3 seconds after it was catapulted, right? So you write the whole sentence as your answer. Correct? Simple as that. Now, as I was talking about, let's look into the alternate way of doing it, right? Now, I'll show you the alternate method. You'll really love it. And what we could do is actually, in the given equation, which is h equals to minus 1.25t squared plus 7.5t plus 2.5, we could take minus 1.25 as a common factor and see what happens to the equation. If you divide plus 7.5 with minus 1.25, what do you get? You get negative 6, right? T. And 2.5 is twice, we get negative 2. Do you see now? The quadratic equation is so simple. That is the beauty. Equating h to 0 since it hits the ground, right? It hits the ground as we did earlier, equating h to 0. You understand? So it makes a lot of difference. You avoid all the mistakes of, sometimes putting the decimal at the wrong place, for example. It matters. You can always join my classes by sending an email on globalmathinstitute at gmail.com. That may be your success path, and we could be part of your story. So, let's continue. Now, definitely, we are going to use the quadratic formula once again. However, the value of A now is just 1, value of B is minus 6, and that of C is minus 2. So simple as that. Do you see that? And once again, we'll calculate the value T, which is minus of B, which is 6, plus or minus square root of B squared. So let me write 6 square minus 4 times A is 1 and C is minus 2 divided by 2 times 1. Do you see how simple it is as compared to last time? Of course, when you calculate the positive value which you are going to get will again be 6.3 seconds, right? Do this calculation and appreciate how we could actually simplify our problem solving and get the best out of the skills learned. Great. Let's move on and do part B and C now. Now, I've clubbed in the part B and C. As you can see, we'll now find two things about this equation: the maximum height reached and when does that maximum height reaches. Clearly, what are you going to use? The completing the squares method. So you know the strategy. Well, it makes all the difference. In case you want to learn and do excellent, you can always contact me on globalmathinstitute@gmail.com. Now let's see. How do we do this part? Well, I will prefer to work with my simplified equation where I factored out minus 1.25, which gave me t square minus 60 minus 2, correct? Now look here. If I do completing the squares with this simplified equation, how simple it is. Imagine doing half of the decimal numbers and squaring them. It would have been really complicated. And that is where the students mess up and get wrong results. Perfect. So let's do the right way, which is minus 1.25. And now completing the squares, we have t square minus 60. What do? You take half of this number, add and subtract, correct? It's square. Half of this number is 3. So you add 3 square and you subtract 3 square, correct? Perfect. And then you get what? You get minus 1.25 within brackets. T minus 60 plus 3 square forms a perfect square, which is t minus 3 whole square. And here we have minus 9 minus 2, which is minus 11. So you see, we combine the three terms as a perfect square. Makes sense, right? Let's rewrite this as minus 1.25, open the bracket, right, times t minus 3 whole square minus. Minus and minus becomes plus 1.25, and that is 11 for you. Perfect. And you can now write down your vertex form of the equation and answer the question. So it is minus 1.25 means it is a parabola which is opening upwards, right? So you get a maximum. Perfect. Minus 1.25 times t minus 3 whole square plus 11 times 1.25. Let's do it. 11 times 1.25, which is 13.75. Correct? Now you can easily answer the question, right? Part B is when is the maximum height reached? So you can say maximum height reached at time t equals to 3 seconds, right? And when will the ball reach the maximum height? And what is the maximum height? There are two things, right? What is the maximum height? At t, this maximum height will be what? 13.75, right? Meters. So include units in your answer. That is the vertex of the water balloon which was catapulted into the air. Makes sense? So I hope it makes a lot of sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, it'd be great. Remember, continue supporting us. As you know, we are trying to reach people in remote areas with free education, especially math videos from Anil Kumar. Thank you and all the best.